All right, folks. Today we are going to study angles of polygons. And so after today's lesson, you should be able to figure out the sum of the measures of the interior angles of a polygon to classify figures and solve problems. I don't think we're going to get to that second bullet today. So let's just focus on the first one. Tomorrow we will hopefully hit the second bullet, which is to find the sum of the measures of the exterior angles of a polygon. But you never know what we'll get to. Let's see what we can do. So, the first thing that we want to do is realize that polygons that have more than three sides have what's called a diagonal. And this will help you to visualize how many degrees will be in a polygon. So, this first one here right here, we have a quadrilateral. It's a rectangle, right? And if I draw one diagonal there, I have how many triangles? I have 2 triangles. And since each triangle has 180 degrees in it, 2 times 180 equals 360 degrees. So all quadrilaterals are going to have 360 degrees. Similarly, I can do that with a pentagon. And I can draw 2 diagonals there without crossing my diagonals. In which case, I now have 3 triangles. And again, each triangle has 180 degrees. And so 3 times 180 is, yes, 540. Yes? And then the next I have my hexagon. And again, I want to do this all from one corner. So I'm going to draw 1, 2, I have 3 triangles, or 3 diagonals, which results in 1, 2, 3, 4 diagonals. All right? 4 triangles there. And 4 times 180 is going to give me 720 degrees. So, next I have the heptagon, and I can draw 1 diagonal, 2 diagonals, 3 diagonals, 4 diagonals. That results in 1, 2, 3, 4, 5 triangles. So I have 5 triangles times 180 degrees, and that is going to get me 5 times 180 equals 900 degrees. So there are 900 total degrees in a heptagon. Lastly, we have an octagon, and I'm going to draw 1, 2, yeah, that wasn't the most straight line, 3, 4, 5 diagonals. And I end up with 1, 2, 3, 4, 5, 6 triangles. 6 triangles times 180 results in 6 times 180 equals 1,080 degrees. All right. So in an octagon, there are 1,080 total degrees. And so, if you look, all right, well, let's take a look. What did we end up doing every time? We ended up taking the number of sides, and we reduced it by 2, right? We ended up multiplying by 8 minus 2, 7 minus 2, 6 minus 2, 5 minus 2, 4 minus 2, to get the number of triangles that we have. And so here ends up being our formula. S, which is the measure of all the sum of the measures of the interior angles, is going to equal 180 times n, which is the number of sides, minus 2. That's our formula. In this one here, it says find the sum of the measures of the interior angles of a dodecagon. Again, like we have done all year, we're going to start with writing our formula. So we're going to just write down S equals 180 times n minus 2. Then it's a dodecagon. How many sides are in a dodecagon? You're right, there's 12. So we do 180 times 12 minus 2. Using order of operations, what do we want to do first? Do we want to multiply, or do we want to do that which is in the parentheses? Correct. We'll do the parentheses. So we have 180 times 12 minus 2 is, of course, 10. Oops. (180 times 10 is, of course, 1800. So there are 1800 degrees in a dodecagon. Moving on. Next one. Example 2. The measure of the interior angles of a regular polygon is 160. Find the number of sides in the polygon. All right, now we're just going to work backwards. Of course, we are going to start with what? Yes, the formula. And what is the formula? S equals 180 times n minus 2. Now what do? Substitute. In which case, the measure of it, ooh, this one's an interesting one. All right, the measure of an interior angle is, okay, so the measure of an interior angle of a regular polygon is 160 degrees. And it wants us to find the number of sides in the polygon. So, wait a second. We know what the angle is, one angle is, and it wants us to find the number of sides, but it doesn't tell us the sum of the sides. How can we figure out this? How are we going to do this? Let's think for a second. Some angle in a regular polygon, to figure it out, what we would do, say if we had a triangle, we would take 180 degrees, and because that's the sum of all the measures of a polygon, and then we would divide it by 3, right? So similarly, we can, if you think about it, to find the angle of any regular polygon, we would take the sum of all the angles in that polygon and divide it by the number of sides. Well, in this case here, we know that the measure of the angle is 160, so we can substitute in 160 for the angle, and then we have S over N. Let's solve for S. And so to solve for S, all we would do, of course, would be to multiply both sides by N. On the right-hand side, my N's cancel out, and I have S equals 160N. And so now, let's substitute in for S 160N. So I have 160N equals 180 times N minus 2. What do I want to do next? Yes, distribute. So I'm going to just bring my 160N down. 180 times N is 180N. 180 times negative 2 is minus 360. Then, of course, I can just subtract 180N from both sides. When I do that, I have negative 360 on the right, and I have negative 20N on the left. Of course, then I will then write down, or I'll divide both sides by negative 20. And N equals 18. Yes? All right, everybody do me a quick favor. All right, this formula right here, A equals S over N. Please, 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 on your formula sheet, on page 2, I want you to write it at the bottom. Tools, desktop annotate. All right, so go ahead and all the way down here, we have our formula here. S, there we go. S equals 180 times n minus 2. Also, please write A equals S over n, and then also explain A is the measure of one angle in a regular polygon. All right, everybody go ahead and copy that on your formula sheet, because you will need this for the quiz, right? And you can use your formula sheet for the quiz. All right, everybody have that? Good. Moving on. All right, we're going to skip that. Okay, now let's find the measure of x. Okay, so we have, how many sides do we have here? We have, I'm going to start here. We have 1, 2, 3, 4, 5 sides, right? So the first thing that we want to do is we want to figure out the total measure of angles in this thing. So S equals 180 times n minus 2. So S equals 180. What is n? Yes, in this case, n is 5. 5 minus 2 is, of course, 3. And 3 times 180 is 540. All right, how is that going to help us? Who thinks they can come up with a formula? Yeah, very good. All we have to do is add up all of these. So if we do x plus 20 plus x plus 5 plus x minus 5 plus x plus 10, that of course is going to equal 540. What do we do now? Yes, combine like terms. I have 1, 2, 3, 4, 5 x's. So we have 5x, and then we have 20 plus 5, so that's 25. Minus 5 is 20. 20 plus 30 is, or 20 plus 10 is 30. So 20 plus 30 equals 540. All right, let me double check this. 20 plus 5 is 25, minus 5 is 20, 20 plus 10 is 30. All right, good. What do I do next? Subtract 30. And so I have 5x equals 510. And so I divide by 5, and I get x equals 510 divided by, I'm guessing that's 101, yes? 510 divided by 5 equals 102. Sorry. That is why we use calculators. All right. Very good. All right. The last one here is really simple. If the polygon is convex, then the sum of the measures of the exterior angles, one at each vertex, is 360. Okay? And again, exterior angles are, if I did this, right? That's 1, that's 2, this is 3, and that's 4. The sum of those measures is going to be 360 degrees. That is true for every polygon, okay? If it's convex. And so, find the measures of the exterior angles of an octagon. What we're going to do is we are going to take 360 and divide by n. And so in this case, since n is 8, we're going to do 360 divided by 8, And that is going to give us